22 alone, and April 28, a single day, there were multiple locations were highlighted for the heat wave, heat stress. The maximum temperature increased like anything. So if you think about the flood also, like in Mumbai, in 2005, when the major flood event happened, everyone was thinking this is a 100-year event. But that kind of similar event happened within 20-year period. So that is in 2007, even recently in 2023 also. So likewise in Chennai, there was a mega event in 2015, but followed by the same. Nowadays we are getting every year. It may not be a mega flood event, but we are like flood inundation here even in Chennai every year during the monsoon. But the other side, every year we also hear about the water scarcity in Chennai. In summers, people suffer for water, and in winter, in monsoon, water will be there everywhere. So that was the situation even in our country. So this all, it's motivating us to look into the extremes. These extremes become so frequent. What's happening? Why there is a change in the extremes? So if we simply ask this question to anyone, immediately they address to global warming. But yes, global warming is one of the reasons, but it is not only the reason. So here, if you see the global maximum temperature, the top panel shows the maximum temperature, and the bottom panel shows the minimum temperature. Both are increasing, but the rate at which increase matters a lot, because the nighttime temperature increases just depending on the moisture availability. That is, you can say that dew point temperature. And because of these things, because of more warming, what's happening? Huge amount of moisture is transporting the atmosphere. At the same time, we have so much aerosol loading also. So this all, it's kind of altered the hydrological processes, hydrological cycle. Even the microclimate is more important, because small microclimate changes now resulted as a global change. So it is not like the temperature is increasing everywhere. It's not that temperature, because of temperature rise globally, the precipitation is going to increase. We cannot say that. There are some locations it's going to be dry. There are some locations it's going to be very wet. So the rainfall uh, distribution is also changing. So if you are considering a basin, if you're considering a basin, suppose this basin in Chennai, it is 1980, and this is in 2010. You can see how the urbanization has developed. So it is not about the climate. Even the urban flood causes more inundations, right? That is because if you take for a same rainfall distribution, for example, in 1981, the rainfall happened, for example, 10 millimeter rainfall happened in a day. Okay, if you suppose consider a 10 mm rainfall happened in a day, and the same rainfall is happening in 2010 also. For example, 10 centimeter. Okay, so the same rainfall, you can see the hydrograph the peak might be this in 1980, but due to the encroachment, due to the impermeable surfaces, the peak flow will increase because the infiltration will decrease. For a same event itself, the peak is increasing in the urban setup. But what happens if the rainfall distribution also changes? High intensity and short distribution events. So that will be even more. This flood inundation marks will be, this hydrograph will, the peak will be earlier and it will be high. Right? So this extremes, how we can look into a statistical point of view. If you're considering extremes, this changes with a geographical context. For example, The daily maximum temperature in Delhi would be a termed as a heat wave in France. And these extremes are part of our climate system. People are already adapted to their localized extremes. Northwest people in India itself, Northwest people know how to manage the dry events because they live in that dry weather for a long period. Likewise, the Northeast people, they know very well how to handle the flood events, the wet events. Even 40 centimeter rainfall and all, it's normal for them. It is not going to result into a flood because the system is adapted towards that. So these extremes are highly geographic context and we have to study in that. So if we want to study the extremes in a statistical point of view, what we fit the time series into a suitable probability distribution, and the here you can see the tail portions, that is the occurrence of any value above or below a certain threshold is called extremes. For example, here the left side, the red color shows the hot extremes and the right color shows the cold extremes. So we are going to study about this tail portion. Whenever we talk about the extremes, we will study about the tailed portions. So now the precipitation, if you take the distribution, will be something like this, and the heavy tail represents the extreme precipitation. So how the urbanization is playing a role in this. So extremes are becoming frequent. Everything is fine. What is the role of urbanization? So if you consider an urban hydrology, it is like what is that urban hydrology? Urban hydrology means the water cycle. You know, everyone knows the water cycle. The global water cycle, the regional water cycle, that is the occurrence of water from one stage to the other stage. It is an unending process. So it starts with means there is no start or end. For a convenient like evaporation, condensation, precipitation, then runoff, infiltration like that. But in the urban setup, this highly alters by many factors. That is, one is the urbanization in the water cycle reduces the permeability. It is increasing the impermeable surfaces. So the runoff is increasing. So the runoff will increase because of altered infiltration and the groundwater leakage. So you can see in a typical urban setup, there will be very few percentage of infiltration. There will be a huge amount of runoff will be there, and even the evapotranspiration, because the green surface is reducing, the evapotranspiration also will reduce. So if when the green surfaces are reducing, as I mentioned, the discharge also going to be increased. So for example, this is the before what I was showing is for the same rainfall distribution, but you can see here the rainfall distribution is it's also varying. At the same time, the hydrograph also, the peak is coming earlier and it is going to be higher than the normal one. So this is the thing